friends, welcome back to my YouTube channel. Today I am going to present to you a quick guide on quantum computing. So let's start. We will cover introduction to quantum computing, what are the advantages of quantum computing, we'll see what are the limitations currently we have with quantum computing. We'll also see the applications of quantum computing and what quantum computing is going to do in future and how it could help solve some of the biggest problems of our world. Okay, so and we'll summarize at the end of the course like what quantum computing means. So we'll summarize at the end of this course what quantum computing means. Okay, let's start. Introduction to quantum computing. So quantum computing is fairly new technology which is also evolving rapidly. Okay, and is actually uses a especially manufactured or especially created machine or quantum computing machine to quickly or powerfully process a large amount of data, not even large, huge amount of data, billions of terabyte data. It could process in a very short span of time, which traditional computers cannot do using CPUs or GPUs. Okay. So it leverages the power of quantum mechanics, okay, to solve the complex problems, and those problems could be solved in a fractions of time of what traditional computers basically use. Okay, in the quantum mechanics, what we have is the behavior of matter and energy that is used on atomic and subatomic level to perform these calculations. Okay, it takes advantage of quantum properties like particles could be present in a positive or negative state, like two different states simultaneously, like 1 or 0 bits, right? Here we call quantum bits or qubits. Okay, that could represent the state of different calculations or parameters, and using that we can quickly and in a fast and powerful way we can calculate or solve any kind of computer problems. So quantum computing continued, a form of quantum computing that uses the properties of quantum mechanics to perform the operations on data. So it basically uses quantum mechanics algorithms like Shor's algorithm and Grover's algorithm for factoring and searching, and it could then come up with the solution faster. Okay. Currently, it's in early stage and there are many challenges to overcome before large-scale and practical quantum computers can be built. There are some companies, I will show you in later part of this course, which have been built by different companies, okay, to be publicly available as well as privately owned, which are being used to solve the cryptography, drug discovery, or machine learning problems. Okay, and it could also do a parallel processing on data, so that makes it super powerful. Okay, the advantage of quantum computing: it has the potential to revolutionize the way we process data and solve problems. It could enable to solve complex problems that would take classical computers even years and centuries to solve. Okay, those could be solved by supercomputers in a fraction of time. So that much powerful a supercomputer could be. Okay, it can also process vast amount of data in parallel, allowing for more efficient and accurate analysis and time efficient, right? This could lead to a breakthrough in various areas like artificial intelligence, machine learning, and big data, cryptography, a lot of things. Okay, so drug discovery, simulation of drugs or any kind of simulation that would take years to solve, that could be done through supercomputer. Now, limitations of quantum computing. It is still in its early stages and has a number of limitations. One of the biggest is the quantum computers are extremely expensive to be built. Okay, and only a selected few companies who have that much of money or infrastructure, they have been able to build this quantum computers basically, and they are using it now. Okay, traditional quantum computers are extremely sensitive to external disturbances, making them difficult to use in the real world. Okay, Now, quantum computers also require special algorithms to take full advantage of their capability. These algorithms are still being developed and refined, and they require a deep understanding of quantum mechanics to use effectively. So these are some of the limitations on a high level. Let's go to applications of the quantum computing that I have already covered, but let me again give you some examples. So basically it could be used to solve simulation of complex problems of finance, healthcare, logistics, machine learning, AI, or to solve where big data is involved, right? Huge data is involved. So those kind of like census data, astronomical data we have. So those kind of data can be processed through supercomputers to quickly come up with the solution. Okay. It could create more efficient and secure communication network. Okay. It could be used to simulate drug discovery for new kind of drugs for healthcare system, right? So the potentials of quantum computing is very fast and far-reaching in this area. Okay. Now, quantum computing and the future. So, what quantum computing holds in future? Okay, this slide is all about that. Quantum computing has the potential to process and solve complex problems which could take years and centuries for classical computers to solve. So those kind of problems supercomputers are currently solving. Some of the existing supercomputers are already solving those kind of problems and saving us, humanity, a lot of time. Okay. Also, because of the new drug discoveries and changes in the economical or financial problem solving, which supercomputers have enabled, it has saved it has actually had profound impact on our life. So some of the problems that supercomputers have solved in current scenario or in current world, they have a profound impact on our life and the way we interact with the world. Okay, so it could lead to breakthrough in fields such as artificial intelligence, machine learning, and big data. You might have seen ChatGPT and other AIs, right, which are already solving so many problems for the people, right? Similarly, supercomputers are going to solve those kind of problems in future. Now, here is a list of some of the top 10 advanced supercomputers or quantum computers which are currently built by these companies. And here you see the number of qubits or quantum bits which is used to process the data. If you see the most quantum bits being used is by IBM quantum computers, which is the most advanced quantum computer, and it was so here in this list or table. So here in this slide, so this slide is about top 10 most advanced quantum computers, and you can see Google, Alibaba, Honeywell, Sandu, IBM, Cambridge Quantum Computing. So there are so many public as well as private quantum computers are available, which different companies are using to solve some of the world's most crucial problems. Okay, let's go to the next slide. So a quantum computing course involves these courses which one needs to go through and understand, and then they can work with the quantum computer. Okay, so introduction to quantum computing, mathematical foundation for quantum computing, you need to know quantum algorithms and quantum programming. You also do using Q# code, which is a high level programming language, and then quantum error correction. So these are some of the principles to correct the error in the quantum computers or quantum computing programs, right? So these topics you need to understand first to work with the quantum computer. Also, these are more detailed form. I will be putting this in the description, so you can go through these course details, like in each course what you are going to study, and then how you can leverage those knowledge to work with the quantum computer. Okay, these are some free courses available, and the link is also given. I'm going to put this in the description box, so you go to those links and you can freely study or enroll yourself to those courses, and you can learn about the quantum computing. And here we are concluding this short guide about quantum computing. So basically, quantum computers and quantum computing has large impact on the lives of the people and humanity. Okay, and basically some of the breakthroughs in different areas of our life, like artificial intelligence, machine learning, drug discovery, are being made by using quantum computers. So you can understand how much we are getting impacted and why we need to learn and know about the quantum computing. So that's all for this course. I hope you enjoyed it. Please like, share and subscribe to my YouTube channel, and we will connect back in the next course. Thank you.